In this video, we're going to be talking about 3 major reasons why your shading breaks. Let's go. Look, modeling is important, I know, but so is everything else in the design process. In our free Hard Surface Jumpstart course, you will not only feel more comfortable with hard surface modeling, but also confident with rendering and excited about your new game-changing portfolio. Link is in your video description. Let's get started. Hi guys, Ryuu here from Blender Bros, so let's get started. So there are 3 major reasons, not the only ones mind you, but the major ones, why the shading on your model is breaking. One of them is going to be bevel overshoot, the other one's going to be non-manifold geometry, and the third one's going to be bent faces. Let me show you what it's all about. So first one's going to be bevel overshoot. This one is really easy. Bevel or geometry overshoot happens when the geometry overshoots on itself, like here. So the edges literally flip on themselves. And you have to be very careful when you're, for example, either running this kind of an inset or when you're trying to bevel something too hard. Because when I press 3 here, you can clearly see that what's happening, the bevel, if you look here in this area, the bevel is going to overshoot on itself. You see, boom, one edge goes to the left and the other one goes to the right, and geometry literally gets flipped inside out, which is why you're seeing it in red. Okay, and by the way, if any one of you is wondering how I had this set up, because I had actually quite a few questions about it, it's really easy. Alt V with hard ups and turn on face orientation. Go to edit preferences and then go to themes, then go to 3D viewport, go down, and here on the face orientation move this alpha slider to 0. So you don't see the blues and save prefs, yeah? But you only see the red. So when the face is flipped, then you're gonna be seeing it. Now, second problem with shading is gonna be when you have either flipped or non-manifold geometry. Now, what is it, right? Flipped geometry, basically what it means is that you have the red geometry, which is facing inside of the model, flipped outside. So if I'm gonna go here and Alt N and flip, now the inside of this cube is facing outside. It's like flipping a jacket inside out, okay? So when I'm gonna run a bevel here, you see the bevel wants to go this way, where in fact it should be going down. But because the face is flipped, it's just going the other way. So it thinks it should be going this way. So this is incorrect. And this is going to cause a lot of problems on your models, okay? Now, this may happen quite often when you're, for example, using booleans, such as, for instance, union booleans, where the surface of both of them is the same. So if I'm going to go Shift the X and put it here, and I'm going to scale this a little bit like that, and I'm going to, boolean them together. So go to Q, and then booleans, and then union. And even if I switch here to exact, okay, and I'm going to apply that, so operations multiply, there's a good chance I'm still going to be left with some crazy geometry. See, that is non-manifold geometry. It's not supposed to be here, okay? See that? This is just weird. So what you need to do, you need to clean that. You can clean it with hard ups by going to Q and operations and clean mesh. This could help clean the geometry. If it doesn't, you can use other tools, like for example 3 from Machine Tools. Or you can use the 3D print toolbox, which is a Blender native add-on. Just enable it, and you can go here and go to clean up and make manifold. And this will basically clean your geometry. So if I press Shift 3 to remove the cutter, you can see clearly that this geometry was cleaned up and there are no crazy faces or verts inside, right? Sometimes when you're, for example, using stuff like bisect modifiers, you may end up with a face inside of a geometry. So let's say we loop here, and I'm going to press F to create a face inside, and now you can't see that, but there's actually, right, a face inside here, see in the middle. So if I wanted to, for example, grab this edge here and bevel it, I can't do it because it's not manifold, right? So again, operations clean mesh, and then, everything should be fine. If this doesn't work, you can go with machine cleanup, so 3, and then turn on faces, and you see I removed one face. So now if I want to bevel this, I can do that. So there are many tools that you can use to auto clean your mesh. Now, speaking of booleans, I want to go back a little bit to these to the overshooting problem. So if I'm gonna create a boolean here and I'm gonna apply this, I want you to pay attention how these connecting edges were created by a Blender. Okay, this is not ideal, right? So sometimes when you have these kind of connections, you may have problems with, for example, bevels, okay? Because these edges gonna be creating pools. And in this case, everything is fine. But let me show you something interesting, okay? So I'm going to create another cut in here, right, like this. And I'm going to apply this, okay? And then I'm going to connect these two together like that. And I'm going to remove one of these edges, okay? And now watch what's going to happen here, right? Bevel, and you see this pull here. This is what this edge is causing, okay? Watch. If I'm gonna grab now this knife here and run a cut like this, and I'm gonna remove this edge, you see this pull is gone. So it's very important the way how you run your connecting edges. Same here, you see this pull here in the corner. Watch, if I remove that, it's gone. This is gonna clean up your geometry. So when you're creating cuts like this, okay, what I recommend you do is run a cut with a knife, okay? And then you're gonna create an edge. So when you apply your boolean, your connecting edge is already in place. This is especially very important when you're creating something like an array, okay? So let's run an array here like this, right? And let's just run it like that, and boom. And you can clearly see how these edges will be created, right? But if I'm gonna run a cut here, press K and slice it, you know, this is gone. Now this problem again is caused by overshooting bevels, meaning the bevel is literally too big. So you need to, you know, lower down the bevel so it will not overshoot on itself, okay? So that's basically two of these major issues that cause shading problems, okay? And the last problem is gonna be bent faces. So let me just show you what I mean. Let me grab a cylinder in here. I'm going to create 25 edges, whatever, doesn't matter, and grab it here and move it out like this and scale it down, actually scale it up, and we're going to, you know, difference this, okay? And then I'm going to apply some matte to it right here, and we're going to sharpen this, and we're going to bevel this, right? And now you're going to be able to clearly see that we're going to have some breakages of shading, okay? So, for example, you see this breakage here. The light is breaking on this part here. And what's causing it is that the reason for that is because these faces are simply too big. So this face, right? This face, okay, is on a curvature, right? And this face is too big to be bent on this distance. So what you need to do, usually, you need to create smaller geometry so the faces don't get bent, and this is what's usually causing shading problems. So if I had the same sphere, right, but I subdivided it, okay, so it's going to be more dense, okay, you know, it's going to be way more dense, right, you know, kind of like this, okay, and this geometry is going to be more supportive in terms of shading because the, you know, smaller quads, yeah, or smaller, they don't have to be quads, they can be n-gons, but the size is what's important, okay? If you want a perfect shading, that's another story. You probably want to go with something like normal transfer or, you know, other techniques, but or sub D, for example, right? But in this case, you know, the smaller quads simply can accommodate sharper bend on the surface. There's one more problem with bent faces. So let's say you have maybe this kind of a situation here, and we're going to slice it. So let's grab an angle and slice it here like this, right? And you're gonna have a multiple angles here. Clearly you can see that, right? So this face is flat, but if you're going to start moving one of these points, right, this face is no longer flat, okay, it's bent, and this is gonna create shading problems. You see that it's actually bending here. So in order to, you know, create this kind of a curve, you need to introduce more geometry here to ease off this curvature. Again, same situation, but this happens quite often when you model something and then you move a little bit one vert to just, you know, maybe combine verts together or clean some place and remove some unnecessary geometry, and you move the wrong vert, and this is what's gonna happen, okay? And the same goes to cylinders, okay? So when you have a cylinder like this, my blender crushed, so let me show you here very quickly. So when you have a cylinder like this, right, I'm going to apply that and apply some matte here and go to shade editor. So now this is a bit dark, let me just make it a bit brighter so you can see, okay? Cool. So now we have even faces here, right, all over the place, which means the shading is smooth. But watch what happens when I'm going to introduce more edges to one of these faces, right? The shading is going to break. So when you have uneven spaces, or, you know, like if I move this edge a little bit here, you're going to have the same problem. It's going to be a bit flat here, see that? So you gotta be very careful. This can be very easily fixed by using the spacing option in Blender. So if I'm going to combine these together and go to this, let's just clean it with machine tools, select that, and you need to have installed the add-on called Loop Tools. It's Blender add-on. Right click here and go to Loop Tools and Space, and this will space all these threads equally. Then I'm going to Alt X with Mesh Machine to the bottom, and then I'm going to remove this edge from the bottom, and it's fixed. Okay, so that's one of the ways of fixing this problem. So anyway guys, that's it for the video. These are 3 major causes of shading problems in Blender for hard surface, and if you're going to pay attention when you're modeling and do not let these kind of things creep up on you, then your shading should be fine. Okay, and the rest is down to practice. So watch our videos, grab our courses, enjoy. Thanks for watching. I'll see you in the next one.